Right, we've reached the end of this case study on rock, paper, scissors, during which time we've looked at higher order functions as well. So let's just recap a bit what we've done. We've seen that higher order functions can be functions that take functions as arguments, like map and filter and so on. They can be things that give us functions as results, these curried functions like the add one argument function that returns a function that adds that to whatever number is passed to it. And then functions that take functions as arguments and results. Things like compose, which we looked at in a previous activity, and iterate, which you defined for yourself. I'm going to talk about iterate in a minute, but also I just wanted to talk a bit about how we've used functions in practice in defining our rock, paper, scissors activity and in defining a function to play one strategy off against another. And here's a particular solution for that. It's called play 2. It takes two strategies, a left and a right strategy, and a number of turns. And it calls the auxiliary function with 5 arguments, where the third and fourth arguments are the lists of plays so far for left and right. Now when we get down to 0, we process those lists somehow, give an overall result and so on. I'll leave that to you to think about. But in the general case, when we've got n turns still to play, what happens? Well, let's look at what happens with the plays from the left-hand side. As one of the arguments, we have plays L, and you can see that gets passed to strategy R. So we get the next play for R by applying strategy R to plays L. Where do we get our next left play from? Well, what we do is we apply our strategy, strategy L, to the opponent's plays, plays R. And so finally you can see now that we pass in the tail recursive call, we add play L to the front of plays L, play R to the front of plays R, and we subtract 1 from the number of turns still to go. So we get the next play for left by applying the strategy for left to the play so far for right, and conversely. So it's a very nice symmetrical arrangement. And there we have it. But it's nice to be able to have that completely parameterized both by those two strategies, which are obviously functions. And we can encapsulate any strategy within there. And you saw that you can do some quite sophisticated things by way of defining strategies. Okay, the other thing I wanted to talk about was the iteration function. And because here, what does iteration do? Well, iterate takes a number and then it returns a function whose role is to take a function and compose it with itself n times. So iterate 0 will take any function you like and return the identity function. Because doing f 0 times means doing nothing to the argument. Otherwise, what do? Well, we want to apply f n times. One thing we can do is use ordinary recursion over numbers and iterate f n minus 1 times and then apply f one more time. Now one way we can do that is to compose together the iterate and f, and that's what you see here. So the final line there is at the level of functions. So we've got something really quite high level here. And using the fact that we can define functions anonymously using fun, which you might call lambda in another language, and then with compose we saw that we could actually have functions as arguments and return the result, which is itself a function. So there we have it. As a little exercise, you might think another way you could define iterate might be using map and fold R and compose. I'll leave it to you to think about how you might do that. Okay, so we've seen these higher order functions. I've explained what that means, functions as arguments and functions as results. And we've seen that applied in an example of rock, paper, scissors. If you're interested in rock, paper, scissors itself, Google for rock, paper, scissors. There's some nice pages about the World RPS tournament from 2006, admittedly, but nonetheless interesting pages there, and a number of articles and so on about devising strategies to play rock, paper, scissors. So I'll leave it at that. What we do next is to go into the first part of our masterclass, which forms the end of this this mini MOOC. This was a masterclass recorded in the studio with myself and Joe Armstrong and Francesco Cesarini. We'll expect to be putting all of the masterclass out in the next month or so, but for the moment what we're doing is making the final bit of the masterclass available to you as part of the MOOC. And what I talk about in there is functional programming applied to language processing. I explain what that means, and then we can define all sorts of different things, different ways of dealing with expressions and so on, in a functional way. And it will give you a chance to see illustrated again all the things I've been talking about in this mini MOOC so far. So, time to move on to that.